What if an asteroid is heading straight for Earth right now and we don't know it? Sounds terrifying, right? But what if I told you that scientists have been working on ways to stop that from happening? From high-tech spacecraft to global collaborations, there's a lot more being done than we realize to protect our planet from these cosmic threats. Have you ever wondered how we might stop the next asteroid impact? Well, today, we're diving into the fascinating world of planetary defense and the strategies scientists are using to keep Earth safe. Let's explore how it all works. Early detection and tracking. Did you know that the first line of defense against a catastrophic asteroid impact is finding it before it finds us? Asteroids and comets are constantly zooming through space, but many of them fly under the radar until it's almost too late. That's why scientists are always on the lookout for near-Earth objects. Early detection isn't just about spotting an asteroid, it's about tracking its orbit, predicting its future path, and gathering as much information as possible to determine if it's a threat to our planet. NASA's Planetary Defense Coordination Office is leading the charge in this field, working tirelessly to catalog and monitor these space rock wanderers. In collaboration with international space agencies and observatories, PDCO tracks thousands of these objects using powerful telescopes. But tracking them is just the beginning. By gathering data on an asteroid's size, speed, and composition, scientists can accurately calculate whether it poses a real threat and how much time we have to react. What's truly fascinating is that the more we learn about these celestial bodies, the more we realize how diverse they are. Some asteroids are just small chunks of rock, while others are massive, making early detection even more critical. Early warning systems are getting better by the day, but time is of the essence. The key to saving our planet from an asteroid impact may lie in spotting them years or even decades before they make their move. So, next time you look up at the stars, just remember that a team of dedicated scientists might be tracking a near-Earth object, ensuring that we stay one step ahead of a potential cosmic disaster. Kinetic Impactor technique. Imagine this. A spacecraft, traveling at an incredible speed, crashes into an asteroid just like a cosmic game of bumper cars. Sounds wild, right? Well, it's not science fiction, it's one of the most promising methods that scientists are testing to prevent an asteroid from wiping out life on Earth. This method, known as the Kinetic Impactor technique, involves sending a spacecraft directly to collide with an asteroid in a controlled impact. The goal isn't to destroy the asteroid but to change its course by imparting just enough force to alter its trajectory. NASA's recent success with the Double Asteroid Redirection Test mission proved the technique works. The DART spacecraft was launched with one specific target in mind, Dimorphos, a moonlet orbiting a larger asteroid called Didymos. When DART crashed into Dimorphos at speeds of over 14,000 miles per hour, scientists were eager to see how much the impact would shift the asteroid's orbit. The result? It worked. Dimorphos's orbit was altered by a noticeable amount, proving that a carefully timed collision could redirect an asteroid's path. This is huge. If a large asteroid were headed straight for Earth, this technique could buy us precious time to avoid disaster. The idea is to use these kinetic impacts to push asteroids off course early enough to prevent them from becoming a global threat. And while DART's mission was just the beginning, it's an exciting step toward protecting our planet from the unseen dangers of space. Think about it. Our planet's safety could one day rest in the hands of spacecraft designed to give asteroids a cosmic nudge. Who knew saving the world could be done with a little bit of space-age bumper car technology? Gravity tractor method. Picture this. A spacecraft silently hovers near a giant asteroid, gently tugging it away from its path, not with brute force, but with the invisible power of gravity. It sounds like something out of a science fiction novel, but it's actually one of the most innovative ideas scientists are exploring to save Earth from an asteroid impact. This technique, known as the gravity tractor method, relies on the subtle yet powerful force of a spacecraft's gravity to gradually alter the asteroid's orbit over time. Here's how it works. A spacecraft would fly to a near-Earth asteroid, positioning itself in such a way that it remains in the asteroid's gravitational influence. Without any physical contact, the spacecraft's gravity would create a tiny force that slowly pulls the asteroid in a different direction. It's a long-term solution, requiring years or even decades to have an effect. But the beauty of the gravity tractor lies in its non-destructive approach. No explosions, no risks of fragmenting the asteroid, just a steady push made possible by the spacecraft's subtle gravitational pull. While the method sounds simple in concept, executing it is incredibly complex. The spacecraft needs to maintain a precise position for an extended period, using thrusters to keep its course perfectly aligned with the asteroid. Scientists are currently refining the technology and simulations for this technique, testing how much force is needed and whether it can be achieved without drifting off course. But if successful, the gravity tractor method could be a game changer for planetary defense. It's a peaceful, high-tech approach that offers the potential for redirecting asteroids in a way that could save Earth without a single violent impact. Nuclear disruption and deflection. Now let's talk about the ultimate backup plan: nuclear power. When it comes to saving the planet from an asteroid on a collision course, sometimes the situation calls for something more drastic than a gentle nudge or a slow pull. That's where the nuclear disruption method comes in. This method involves detonating a nuclear device near or on an asteroid with the goal of either deflecting it or breaking it apart. While it sounds extreme, scientists consider it a last resort option, especially when time is running out. There are a few ways this could work. The most straightforward approach is to detonate a nuclear bomb near the asteroid, using the explosion's energy to shift its trajectory. In this scenario, the asteroid might not even break apart, it could just be nudged off course. But if the asteroid is large or its path is too critical, a more direct method could be employed, such as a direct impact with a nuclear device. The blast would send pieces of the asteroid flying in different directions, hopefully causing the fragments to scatter away from Earth's path. But there's a catch. This could cause even bigger problems if the asteroid fractures into too many dangerous pieces that still threaten our planet. Despite its risks, this method is seen as a viable option in case an asteroid is too large or too close for any other strategies to work. The nuclear option could give us a fighting chance, but it's not without its challenges. The timing and precision would need to be flawless, and experts are still working on determining how to use this method without unintended consequences. It's a high-stakes plan, but with the right preparation, it could make all the difference in saving life on Earth when an asteroid is headed straight for us. Asteroid surface modification. Imagine having the power to change the way an asteroid interacts with sunlight, transforming it into a cosmic time bomb ticking to the rhythm of the sun's rays. That's the essence of asteroid surface modification. This technique involves altering the surface properties of an asteroid to manipulate its orbit by making it more responsive to solar radiation. It's a subtle yet powerful method of planetary defense that could give humanity a critical edge in averting a disaster from space. One of the most talked about strategies in this category is applying a reflective coating to the asteroid's surface. This coating would increase the asteroid's albedo or reflectivity, causing it to absorb and re-emit sunlight differently. The result? A change in the way the asteroid moves through space due to the way sunlight pushes against it. This effect, called the Yarkovsky effect, is a natural force that causes asteroids to slowly shift their orbits. By making small but precise changes to the surface of an asteroid, scientists could trigger enough of a shift in its trajectory to safely avoid Earth. Surface modification is a fascinating idea because it's non-invasive, using the asteroid's natural behavior to our advantage. Instead of slamming a spacecraft into the asteroid or using explosives, this method quietly alters its course through the power of light. Of course, there's a lot of research to be done to figure out the best materials and techniques for coating asteroids, but it's an innovative approach that could potentially deflect asteroids far in advance of a potential impact. It's like using sunlight to steer a gigantic rock through space, nothing short of cosmic ingenuity. International collaboration and preparedness. When it comes to protecting Earth from asteroid impacts, one thing is clear: no single country can do it alone. Planetary defense is a global effort, requiring coordination, resources, and expertise from around the world. Asteroids don't recognize borders, and neither can our efforts to stop them. That's why international collaboration is at the heart of how we're preparing for potential asteroid threats. Space agencies like NASA, the European Space Agency, and other global partners have been working together to develop and refine methods to track, study, and divert asteroids. The joint missions, such as NASA's DART and ESA's Hera mission, demonstrate the power of collective effort. The DART mission, for example, successfully impacted the asteroid Dimorphos, but it was just the first step. ESA's Hera mission will follow up by studying the aftermath, providing critical data on how effective the Kinetic Impactor technique really is. But it's not just about missions. Global cooperation also involves sharing data, expertise, and even funding for planetary defense. With many countries involved, the global community can pool resources to develop better detection systems, faster response times, and more efficient deflection technologies. Additionally, international agreements and treaties play a crucial role in creating a framework for how we approach asteroid defense. The idea is to be prepared for the worst while hoping for the best, and by working together, we increase the chances of success. When a real asteroid threat emerges, it won't be the time for individual nations to act alone. It will be a race against time, and only through cooperation will we be able to safeguard the future of humanity. So, as we continue to develop innovative defense strategies, let's remember that saving the world from an asteroid requires the combined efforts of the entire planet, united in the face of an unprecedented challenge. Thanks for watching. If you found this video fascinating, don't forget to hit that like button and subscribe to InnoVision Tech for more mind-blowing insights into the world of futuristic technology. What do you think? Will we be able to stop the next asteroid impact? Let us know your thoughts in the comments below. Until next time, keep exploring the unknown, and stay curious about the incredible technologies shaping our future.